Okay, and this is Chemistry B, Unit 8, Redox Equilibrium chapter, Day 4. We're going to talk about electrochemical cells. Alright, the conversion between chemical and electrical energy is called an electrochemical process. All of these processes involve redox reactions. Electrochemical cells are any devices that convert chemical energy into electrical energy or electrical energy into chemical energy. Redox reactions occur in all electrochemical cells. Now, the most famous electrochemical cells are voltaic cells. These are electrochemical cells used to convert chemical energy into electrical energy. Electrical energy is produced in a voltaic cell by spontaneous redox reactions within the cell. Examples of voltaic cells and what they operate would be a flashlight, battery-powered flashlights, and battery-powered calculators as well. Alright, there are parts to a voltaic cell. One is called the half cell. It is one part of the voltaic cell in which either oxidation or reduction occurs. Typically a piece of metal in a solution of its ions is a half cell. Another part of a voltaic cell is a salt bridge. It is a tube containing a strong electrolyte in which the half cells are connected to. Alright. And three, the electrodes. Electrodes are a conductor in a circuit that carries electrons to or from a substance other than metal. The reaction at the electrode is where oxidation or reduction takes place. Now, at the anode, that is where oxidation takes place. This is where the electrons are produced, and therefore it is labeled the negative electrode. The cathode is another electrode, and this is where reduction takes place. Electrons are consumed here. Therefore, it is labeled the positive electrode. Okay, so the anode is where oxidation takes place. That's where the electrons are produced. Therefore, it is a negative electrode. And the cathode is where reduction takes place. Electrons are consumed here. Therefore, it is labeled the positive electrode. So over here you have a voltaic cell. It is a zinc copper cell. And these steps are not in order. They are always occurring. They're occurring simultaneously. And what we have here is a light bulb attached to the wire so that when the circuit is completed, the light bulb will run. You could have a voltmeter there that would measure the amount of power that you're getting through it. Sometimes a voltaic cell is called a Daniell cell as well, as you can tell. So, number one, electrons are produced at the zinc rod according to the oxidation half reaction. Don't worry about half reactions. Zinc produces zinc oxide, or excuse me, it oxidizes. And that is the anode, which is negative. So you can see zinc loses 2 electrons, so it becomes oxidized. And that is the anode. So that would be right over in here. Number 2, the electrons leave the zinc anode and pass through the external circuit to the copper rod, causing the light to shine if it's present. In other words, if it was a voltmeter, it would be the voltmeter that would go off and tell how much is going through. But in this case, we have a light bulb, so the light goes off. It allows it to shine. The electrons enter the copper rod, interacting with the copper ions in the solution. There, reduction takes place. Alright, that should be Cu2 positive plus the 2 electrons turns into copper. Because copper ions are reduced at the copper rod, it is considered the cathode. And to complete the circuit, both positive and negative ions move through the aqueous solutions via the salt bridge. And that is our steps to a voltaic cell and how it works. Now the uses of the voltaic cell, of course, are dry cells. The dry cells in a voltaic cells are made out of, the electrolytes are made out of paste. We're talking about batteries, which are used for flashlights. Now, they're not alkaline batteries. Alkaline batteries are a little bit different. If you're interested in the alkaline battery and how it's different than a dry cell battery, section 21.1 will deal with that, and you can take a look at it, but it's not something that we need to focus on. The other type of voltaic cell that is very popular, that you certainly are well aware of, are lead storage batteries, or sometimes known as 12-volt car batteries. And what these are 6 voltaic cells which are connected together. All right, each cell produces about 2 volts of power. So 6 times 2 is 12. That's where you get your 12 volts, and it is made out of 2 types of lead grids. And those grids are opposite sides of each other. One side is spongy lead, and that is the anode side, so that's the negatives. And then we have lead oxide, which is the cathode side, and that is the positives. So when you take a look in your text, you'll see the inside of a 12-volt battery, and you'll see these two groups of cells, and you'll see how 6 are connected. And then the third type is a fuel cell. Fuel cells are voltaic cells in which a fuel substance undergoes oxidation and from which electrical energy is continuously obtained. The beauty of these fuel cells is there is no recharging necessary. Simple hydrogen oxygen fuel cells powered the Apollo missions. They are very expensive, and that's why they're not used in more common things during the days.